Imagine a number so strange, so inexplicable, that it's been called the greatest mystery of physics. A number that appears to hold the universe together, literally. A number that even the greatest minds of the 20th century, like Einstein, Feynman, and Pauli, obsessed over. And here's the kicker: it's not some gigantic, complex figure. It's just 1 divided by 137. But don't let its simplicity fool you. This number is the fine structure constant, a value so precise that if it changed by even 1%, atoms would disintegrate, stars would never ignite, and life itself would be impossible. Why does this tiny number wield such cosmic power? And why, after a century of research, do scientists still call it the magic number that refuses to be explained? Today we're diving into a mystery that bridges the quantum and the cosmic, a number that might be the universe's ultimate cheat code. By the end, you'll see why Einstein called it a number written by the hand of God, and why cracking it could rewrite the laws of reality itself. Let's start with the atom. You know electrons orbit a nucleus held by the electromagnetic force. But how strong is that force? Enter the fine structure constant alpha. Its formula, alpha equals E squared divided by 4 pi epsilon naught hc. It's a mashup of the electron's charge, E, Planck's constant, h, the speed of light, c, and the vacuum permittivity, epsilon naught. Together, they spit out approximately 1 over 137. But here's the kicker: alpha is dimensionless. Unlike, say, the speed of light, 299,792,458 meters per second. Alpha has no units. It's a pure number, a ratio that stays the same whether you measure it in inches or light years. That makes it a fundamental constant, a bedrock of physics. Why does this matter? Because alpha governs how tightly electrons cling to atoms, how light interacts with matter, and even the glow of distant stars. It's the universe's dial for electromagnetism, and it's set to 1 over 137. But why this number? As Richard Feynman lamented, it's one of the greatest damn mysteries of physics. You might say the hand of God wrote that number, and we don't know how he pushed his pencil. Here's where it gets eerie. If alpha were just 4% larger, carbon atoms, the backbone of life, couldn't form in stars. A smaller alpha, hydrogen would fuse too fast, turning the universe into a lifeless helium desert. This isn't science fiction. Physicists call it the anthropic principle, the idea that our universe's constants are fine-tuned for life. But is 1/137th a lucky roll of the dice, or evidence of a deeper design? Wolfgang Pauli, the quantum pioneer, was so haunted by 137 that he reportedly said, "When I die, my first question to the devil will be, what is the meaning of the fine structure constant?" Ironically, Pauli died in hospital room 137. Coincidence? Probably. But it shows how this number got under science's skin. Cut to the 1920s. A young Paul Dirac tries to derive alpha from pure math, calling it the most fundamental unsolved problem in physics. Decades later, string theory promised to explain it, but instead it spat out 10 to the power of 50,000 possible solutions. A multiverse of universes, each with random constants. Then came the rebels. In 1998, astronomer John Webb analyzed light from quasars 12 billion light-years away. His bombshell claim? Alpha might change over time or space. Critics pounced, but Webb's team doubled down in 2020, suggesting alpha varies by 1 part in a million across the cosmos. Other clues lurk in ancient nuclear reactors. At Oklo, Gabon, natural uranium fissioned 2 billion years ago. By studying leftover isotopes, scientists found alpha likely hasn't changed in eons. So is it constant? The debate rages. Okay, but why does this matter? Because alpha isn't just a number, it's a mirror reflecting our ignorance. For all our tech, we still don't know why the constants are constant. Think of the universe as a grand puzzle. Each piece, gravity, quantum theory, relativity, fits somewhere. But alpha is the missing piece at the center. Solve it, and we might unlock dark energy, higher dimensions, or even time travel. Or maybe it's a humbling reminder. As philosopher Carl Sagan wrote, "The universe will always be much richer than our ability to understand it." But that's why we keep looking. because every why is a chance to marvel at the cosmos and our place in it. So is 137th a cosmic accident, a message from a multiverse, or proof we're living in a simulation? Honestly, we don't know. But that's the beauty of science. The bigger the mystery, the brighter the thrill of the hunt. Before you go, here's a question. What if time itself is just another constant waiting to be cracked? In my next video, we'll explore time travel, from Einstein's equations to quantum paradoxes. Could we ever bend time to our will? Tap the video to dive in, and if you're craving more cosmic mysteries, smash that subscribe. Thanks for watching, and remember, the universe is stranger than we can imagine. See you in the next one.